So I propose the following. Since we're hopefully client devs that are here, instead of like having a discussion, a high-level discussion, so how the market is going to be and these kind of things, I want to move to some implementation details and some of the things that change on the timing of block processing. I've had some slides that I presented at Flashbots, which I think are actually good for showing the structure of the block and how it changes. So can I just share those and then go over the timeline of a slot again, and then we move into what sort of things worry me on the implementation? Or do you guys think of this in a different way?
Sounds good. Sounds good. Yeah, works for me.
Good. So then let me see, how do I do this though? Most probably I need to do this like this, move this guy out, and then do this guy as a slideshow, which is good. And then, okay, so let me share a window. This one. Okay, so hopefully you can see something. Yeah, and you can even probably see my, yeah. Can you guys see the slides?
Yep.
Okay, good. So this is the Ethereum slot today. And I want to remark on just the difference in slot validation, which is, I think, this important change, which is typically blocks are being broadcast at 2 seconds. To get the block to be broadcast, there's already a couple of hops between the builder and the relay, the proposer and the relay, and then there's the validation at the level of the relay, or at least there's an optimistic validation at the level of the relay. The block is produced, and it's typically arriving to nodes at about 2 seconds, and validators have 2 seconds to execute that block, check data availability, execute the state transition consensus, and attest to it. And after that, we're essentially done for the slot. We don't do anything. So our CPU is consumed in those 2 seconds, essentially, because the other hard computation that we do, which is a slot transition, all of us cache it at that moment anyways. So on ePBS, this is going to change, and this is going to change in the following way. At about 2 seconds, or let's say whatever it is, we know that proposers are enticed to try to send their block to broadcast the consensus block as late as possible. So let's suppose that that number is still 2 seconds. It doesn't matter when that number is. Okay, it's going to be the maximum possible that it takes, so that it's still possible to process that block and attest to it. We suspect that that time is going to be much closer to the attestation deadline, because now the block only needs to check the consensus transition. So this is pre-merge information, pre-merge computation, which is only perform the consensus transition state transition function.
Wait, hey POTUS.
Yeah.
Can I ask a question?
Sure.
Why is there any incentive to delay the consensus block here?
Because you can still request bids as late as possible, and that means that the builder has more time to give you a better bid.
Yeah. Okay, makes sense.
So this doesn't change. This sort of timing game doesn't change, but it's actually kind of irrelevant for the network now. It may cause more reorgs, just exactly as they do today. But actually, we're going to go over purchase perhaps, but validators are actually forced to reorg late blocks anyways. And the builder is going to force them to reorder the block. So if the proposer is actually late requesting the bid, the builders are going to actually enforce that block is reordered. So validators will attest at around 3 seconds. In the happy case, which is today, what's happening, a builder will get all of the attestations before the 4 seconds mark. So before 4 seconds, the builder already knows that the block is there, that the block is attested, and he broadcasts the block. This is in a no attack scenario. This is the happy situation. In the unhappy situation, the builder needs to make a decision by 6 seconds. But the usual case, we are going to be receiving our payloads at around 4 seconds into the slot. So the builder, so now the crucial time is CL validation that is still critical, but it's much lower time. Like on Prism, we are executing the state transition in 70 milliseconds. The builder needs to count attestations. I think this is something that we need to implement. So I think this is something that we might want to have an endpoint that says, give me the attestation count for this current block, or give me away from the Beacon API so that the builder queries it and says, this block is strong or not. I think this is a new endpoint that we need to implement. I think it's unfair to request the builder to check this. But anyways, at 6 seconds, the builder makes a choice. It can either send a message that says, I am withholding the payload, or it sends the payload. And here's the crucial change. We don't need to execute that payload. We only need to have it executed by the next slot, by 3 seconds when we attest. We do not even need to check that the blobs are there. We only need to have the blobs by the next slot at 3 seconds when we attest. The only person that actually has to do this before is the next proposer. The next proposer only has, instead of up to 9 seconds, it has only 6 seconds, which is up to the cut in the next slot. So the next proposer needs to have already validated this payload and needs to have already checked data availability. But this is still 9 seconds for attesters for execution and 9 seconds for data availability instead of 2 for both. So I think this is the critical change. And this is all I wanted to go over. I can go on forever. I have like slides for a lot of things. But this is one of the things that I wanted to discuss, the timing change. Are there any questions so far?
So I look at my node for data. I think the block arrival time ranges between 1.5 second to 3.5 second. I think and then it's pretty like evenly like between the two spectrum. I suspect it's just one spectrum, there's no timing gain, and then the other spectrum, there's maximum timing gain. So, but I suppose they will eventually adopt to this new 3 second deadline and just basically broadcast at a 2.5 second or something like that to push it to the boundary, right? I guess another thing to note is that instead of gossiping both consensus and execution today, you are only gossiping the consensus part of the block, which is smaller, which the network propagation time will also be shorter as well. That's another note I have.
Yeah.
Aren't you also gossiping the payload though?
No, the payload is only gossiped afterwards.
Okay, you mean after the first round of attestations?
Right. So the payload is only going to appear after the builder has seen all of the attestations.
Right. And just to clarify, the PTC committee is attesting to availability of the payload, not validity as well.
Exactly. So that's why we need to validate it up to the next 3 seconds. So the PTC only says, I've seen the payload or not. And the PTC doesn't even give you, doesn't even wait for head, except when you have, when you have a discerning view, a different view from the majority of the network. So what the PTC does is the following. If the payload was there and the PTC voted that the payload was there, you're a validator, you got those PTC attestations, and you saw the payload and you saw the payload as valid, so you need to validate it, then you assign to that block, to the full block, you assign 40% more of the weight. So that's the guarantee. But the thing is that an honest validator anyways, in the typical situation, would have the builder's payload as valid and will be its head.
Is there any
Yeah, I'm sorry.
Is there any advantage to like delaying the validation of the payload?
Yes. Yes, it's a huge advantage. You get 9 seconds instead of 2 to validate it. That means that, for example, we're going to have much less, much stronger assurances on port choice, because there's many times that you can't really attest for a block and you attest to the parent because you haven't finished executing the block. This means that if we solve, like, for example, the state load bottleneck, or if we are in a stateless Ethereum, we can just send huge blocks. We can increase the gas limit a lot because we're going to have time to execute them.
So those doing PTC vote, they would be validating the payload as well, right?
No, they own, when you vote, you don't need to validate it. You see the payload with a commitment which has the right hash. So you see the payload where what you validate is the signature of the builder. You check that the builder is actually sending that payload, that the hash that is sending is the right hash that was committed in the consensus block, and that's it. So it's a signature verification that you do, and that's it.
PTC vote is about the availability of the payload.
That's correct. It's literally payload timeliness committee. So I think this is the big win. This is the best outcome of ePBS, and it has nothing to do with actual trust assumptions on the relay. There are ways of doing this purely on the EL by changing EL consensus, which have actually better assurances. But this way, we are only dealing with the CL fork. It doesn't change at all anything on the EL side.
You mean like moving to a pre-state route rather than a post-state route?
Right. So you just only assert on the pre-state instead of the post-state. But this, I think, is a deeper change on the EL. Whether here this change is actually easy.
Right.
Okay, so that's one of the things. There are two other things that I wanted to talk, perhaps. One is implementation, and the other one is design. Let me go quickly over withdrawals because I already mentioned this before. So this is builder safety, and I don't care about this. This one. This is a generic situation that this is a better crowd to discuss. We have from time to time, we're going to be adding on forks more requests from the EL to the CL that are triggered by the EL. And these things now need to be carefully thought about. So this is one complication that happens on ePBS. So this is a good case is withdrawals. Withdrawals are completely determined today without this execution withdrawal from 7002. Withdrawals are completely determined by the beacon state. We include them in the block, and what we currently do is we check that the withdrawals that are expected in the beacon state, they are the same withdrawals that are coming in the block. So that's the check that we do, and then we process the withdrawals. On ePBS, this is going to change. Now, we are going to continue deducting the validator when we sync the consensus block. So we perform the state transition at the consensus side. But now those withdrawals are not fulfilled in the execution layer. When we process them both together, when we have the assurance that the execution block and the consensus block are locked in. Now we're going to process the withdrawals, we deduct the validator, and then we require that the payload to be valid needs to satisfy the same withdrawals that we've already paid out, that we've already deducted. So when the payload appears, the payload is invalid if it doesn't include the same withdrawals that we already paid out.
So for Porus, what it means is that if there is an invalid payload, but its corresponding beacon block will still be valid and will be part of the chain.
That's correct. And that means that we're locked on this situation until a payload appears that is valid. So that means that the next beacon block that is processed is not going to process withdrawals. So there's a hatch at the beginning of processing withdrawals that says, was the last payload full? Was the last block full, in the sense that was there a payload in the last block? And if there wasn't, then that means that the last withdrawals weren't fulfilled. That means that we do not process. The withdrawals for this block.
Actually,
Okay.
this is actually pretty nice in the sense that beacon layer is now a bit decoupled from the execution layer, right? So beacon layer can still chug along while.
That's correct. The
But-
beacon chain is going to continue moving on. Something similar happens with these inclusion lists, but I don't want to go there now because that's slightly subtle. But the point is that whenever we have something that is tied between EL and CL, that both sides need to fulfill something, then we need to check on them. And there's another extra change, which I said, which I don't know, I think this is an API change. It's still not an EL change. But the point is that now the payload, when you process the payload and you fulfill the withdrawals and whatever it is, now you need to put in the state that you actually process the payload. That means that processing an execution payload also carries a state transitions on the consensus side. So that means that the execution payload has a commitment to the post state of the beacon chain. Okay, so the way this works is the beacon node requests the payload, it computes the state transition on the consensus side, and it adds the state roots of that change.
So like technically we kind of have like two post states, one like after applying the consensus block and one after applying the payload.
That's exactly correct. And in for choice, if you read for choice, that's exactly how it works. We still have the block states, which is the post states of including the block. And then we have the execution state, which is the post state after including the payload.
So if a slot is full, as in like we have the payload as well, like is there any reason why we would want to store like the intermediate state as well?
Yes.
Like
Yes, because you might want to reorder the payload. If the builder is malicious and is trying to split the view on whether the payload was available or not, you may have not seen the payload and some other people might have seen the payload. So there are situations where you want to base your block on your head, which is your consensus block, and not the payload.
okay, so you might need to store like two states for each slot in some way, like if you're caching a bunch of states.
That's absolutely correct.
Okay.
And the state is minimal. The only change is essentially, so I haven't gotten there on Prism and implementation. That's one of the few things, one of the next things that we're about to do. But I suspect that the easiest is to just make the processing, because on the consensus side, the only processing that you're doing is you're adding the fact that the state was full, that the payload was there.
So I can reorg the payload without reorging its corresponding beacon block.
That's correct.
So you don't actually really need the post state of the payload, because you just need to know at which payload you're committing to. So you could have the second state transition even later. Am I right? So you could do it lazily.
You definitely can do it lazily. Yeah. So but the state transition is there. And yes, the way that we're going to implement it is going to be, we're just going to cache the fact that the payload was there. And if we need to build on top of the post state, we immediately produce it because it's a trivial change.
But in case of the reorg that you actually really have to do that. Well, at some point you have to do that in any way.
Yeah, you need to rehash, which is the issue. So you need the parent state.
Yes. Yes.
So the issue is rehashing, but the change is just one or two leaves.
Yeah, for us it's pretty fast at just doing that, because everything is cached, in our SSC implementation.
So I don't know what you guys want to go over. So this withdrawals is the canonical example of something that worries me. The other thing, if you want to move the discussion to design, one thing that I was thinking, the people at RIG have been pushing for execution tickets and this sort of like other alternative designs as the end game of this. I do not know how to deal with execution tickets at all, but slot auctions seem to be quite possible and an easy change from this.
I had another question before that.
Yeah.
With respect to local block building. So, so in case I want to build locally, so the flow would be something like I just request my execution node for the payload, and like it will go through the same builder flow, right? Like I will be basically submitting the signed execution payload header with like the builder index as my validator index. And I also have to ensure that I have sufficient balance on the consensus layer to be able to pay out whatever whatever fees I have gotten from like whatever the payload is supposed to be paying me out. Is that right?
You can make it to be 0. So you would request your own bid, right? I think that the easiest to do here is to overload the get payload call, which when you get the payload, then you're gonna get the actual payload, and either the CL can build it or this EL can give you the bid already prepared. I suspect that we want to have the EL be giving the bid because I think builders are going to be using that API, but it doesn't matter. But the thing is that for local payloads, what you can do for the bid is just put 0 in the bid, and you include yourself.
Yeah, that makes a lot of sense.
So another advantage of doing that is that you can actually gossip the payload much earlier as well. You don't have to wait until 6 seconds to review your payload. You can just gossip it almost at the same time because it doesn't matter.
And also another question that I had was that since the you need to maintain a balance on the consensus layer, so in times of non-finality, like with the recent changes on the deposit 6551 whatever, we basically agreed that we don't want to process top-ups during times of non-finality. So like during periods of non-finality, would it be an issue if a builder is not able to top up its consensus layer balance because of some, is that a concern at all? I don't know.
Well, I think we're very far away from this being an issue, right? Validators have 32 ETH. If there are very large blocks that make the builder to run out of funds, I think we're going to be in much deeper problems already by having non-finality long enough. So I suspect this is not an issue.
Yeah, okay, that makes sense.
I mean, sure, if we are a few months without non-finality and every block is just like today, or just a couple of epochs without finality and every block is a 30 ETH block of MEV extraction, there's something wrong with the chain already. If we're extracting 30 ETH on every block on a chain that is not finalizing, there's already something wrong in the chain.
Or with max EV, you can top up your validator balance.
Well, yeah, but you can't in the situation that is described, which is we're not finalizing. Enrico, you should interrupt instead of like raising hands. We're only a few here. I think in total we're like 15.
Yeah, because I just want to switch the conversation to something else. Actually, what Terence said in the first comment was a little bit worrying me, which is in case of latency, we could have non-progressing progressing chain. Like, can you elaborate a little more?
Yeah. So that was my agenda topic that I wanted to bring up, right? So
okay.
Yeah, but then we can move towards there if there's if that's okay. Yeah, I guess we can just move towards there. So the motivation was that I started doing this because of PeerDust was also working on their four-choice spec, and in their first iteration, not the latest one, in their first iteration, they also have block slot voting. So I started comparing these two versions of block slot voting between PeerDust and ePBS to basically see the difference. And then I also like I mean, potency most of this work, right? I also look at the current ePBS for choice analysis, and then we have some sort of safety analysis, right? For example, 2 slots, you guarantee some builder safety. You assume that current proposer and the next proposer trying to team up against the builder and then try to reorg the payload or try to make the builder pay. So we have that type of analysis. We also have proposer safety analysis as well, right? We kind of assume that the current builder and the next proposer are trying to screw the current proposer by using proposer boost. So we have the analysis, but something that I realized that's slightly different is that in the block slot, in the block slot for choice at the peer side, they have more of a liveness analysis. They basically look at what is, so assume the performance is under some really bad network condition, right? And then your chain grower can stop if the block takes 4 seconds to reach to the other clients. And then I think in our case, it's worse because it's 3 seconds, right? So then without some sort of like backup like scheme, because how Peer does is that say today you have some backup scheme, if you have a few skip slots, the backup scheme gets activated, and then your empty slot vote doesn't count for the current slot, it counts for the previous slot. So they have kind of this way to like gradually recover the chain if today everything's under bad synchrony. So I wonder if for our ePBS case, we probably need to do some sort of liveness analysis. I think that's one thing that may be missing. So yeah, I am curious for input.
Yeah, so this is an easy change on for choice, and I haven't added it yet, but after talking to Francesco in Kenya, it was clear that we need the same. So the situation here is that if you vote for empty, then, so if validators, it wasn't really clear now, but so validators vote at 3 seconds, and if they voted that they haven't seen the block, so they vote for the parent, those votes actively vote for reorging the current block. That means if the committee votes for the parent block, then the honest validators will take the parent as head, will not take the current block as head, even though they saw it on time. So that means that if you have a situation where every block takes more than 3 seconds to process, then every block that arrives votes for empty, and empty continues winning. Okay, so that was always the blocker for block slot for choice. And the easy way out is
this applies also to the payload, right? Because there is an active vote on the withhold, so the missing execution payload.
Yeah, go ahead. I don't.
No, I'm thinking like, is there an explicit vote on missing payload?
Well, so but it's only a PTC, right? And that's a cheap statement. This is the payload appeared and said, I'm missing. And the PTC says, I've seen a missing payload.
Right. Well, if that thing actually wins, so that if the majority says, I haven't seen it, you're saying that it's not an explicit vote on existence, it's only on timing. So if you
It is, timing is and existence are the same, right? It's an explicit vote on the existence of a message. Either the message is the payload was there, or the message is the payload was explicitly withheld. And sure, if the majority of the PTC votes for the payload was withheld, then honest validators are inclined to reorg that block, even if they saw it on time and that block had a majority of votes.
So this applies also there. I mean, if you see CL coming late, even a bigger payload with even the blobs definitely will come later as well, if in terms of network latency.
I'm not following. So the proposer sends the CL block and it arrives late, right? In that situation, then the builder will not even send his payload. The builder will send a message saying, I am withholding my payload. Because for the builder would evaluate his own head at that point. So at 6 seconds, the builder says, give me the head of the chain. And the head of the chain will not be the incoming block with his commitment, because the committee hasn't seen that block. So therefore, it attested for the parent. Therefore, the honest majority head is the parent.
Yeah, I see. There is a.
So the builder just says, well, the head is not the head that I committed to, so I'm withholding my payload.
So it's not something that can happen only on the payload. It has to.
Yeah, so I think the payload for this timing issue is irrelevant. Yeah. So in that sense, it's also better ePBS for this issue in block slot. So for peer DAS, this is a little bit more complicated, because in peer DAS, the latency is more than 4 seconds to everything, like availability, execution, executing the payload, and the checking of the CL block. Here, this deadlock happens if every CL block takes more than 3 seconds to process. But still, we need to add a safeguard against that. Otherwise, for choice is just formally not safe. So you just add a safeguard, which is very simple. After 4 or n or whatever constant blocks you've seen empty, you stop voting for empty.
Yeah, Francesco already has a PR for that, so I will just paste it to the chat if anyone's interested. But in his for choice, he doesn't have the notion of empty, which we have empty.
Yeah, for choice is complicated, and I would appreciate a review of that. For choice is really complicated. It's easy to implement because it just changes to a small piece of code. The complication is reviewing the edge cases. I don't know if anyone has started seeing on implementation. I can say that so far for us, it seems that the hardest part is just the networking part. Like you need to add objects for PTC attestations. You need to count them. You need to aggregate them. You need to include them in blocks. So you need to add all of this processing of new objects. But I think so far, this has been the only thing that changes. I'm worried about the fork itself. I do not know how. I haven't even thought about it. Like we're going to switch from attesting at 4 seconds to attesting at 3 seconds. I don't know how hard that's going to be. Those minor things that are part of minor in the design itself might be an issue. Also, this is not an issue. Oh, not a lighthouse, not an implementing. I see. Yeah, so I have no clue how hard those changes are going to be. The fork itself might be hard.
I had another question implementation wise. So like assuming that like ePBS is sort of like the first stage, and like later on, like if we have some other execution tickets or design something like that, would that like, do you know if those designs also have this sort of separation between a consensus layer block and an execution layer block? Because implementing that itself would be quite a lot on the implementation side. So if we like switch to this and then like again we go back to like a place where the like consensus and execution layer blocks are combined, then like the implementation would get really messy at that point. So I was just wondering, like, is this
I can answer that. So there's three answers to that. So 3 different points. One is no one has an implementation. No one has ever thought about an actual implementation of execution tickets and slot auctions and anything that is not this design of ePBS. No one wrote any Python spec of any of this. All of the discussions so far have been more about a higher level discussion of what the right auction or the right block space is. However, when you come to think of, or at least what seems to be obvious, is that when you come to think about how to implement these things, you always keep that separation. There's always the notion of an execution payload and the notion of a consensus block, and they are separated in all of them. In all of these designs, this separation is always there. The second answer is adding this separation actually is not complicated. Like if it's only on the CL side, this is not really implementation complicated. I am much more worried about other changes, like what happens with what happened with attestations. We changed the attestation type, and this was a fucking mess. And I'm worried about this. Like, we're changing the attestation time now instead of type, and I suspect that this is going to be a mess too. But adding the extra, the new state transition, all of these are contained changes. This is the new core function, which just takes a payload and it processes it. It's very simple. Those changes are really simple. At least in Prism's code, those are very, very simple. So that's the second answer. And I had a third one, which so the third one is this. So far, I'm only aware of slot auctions as an improvement and execution tickets as an improvement. And when, yeah, that's right, Alex, we would just change in a timer, but the problem is that this timer happens at runtime. At the fork, it's not really clear how easy is it to change that. But anyways.
Yeah, I didn't want to derail what you're saying, but it doesn't seem terrible.
Yeah, the same.
But
We
I
thought
guess
the
we'll
same
find
about
out.
attestations. That's why. Yeah, I haven't gotten
Well,
there
the
yet.
type, I mean, yeah, the type, because you just have to touch so much more code. But, you know, and this is just like if epoch blah 4, if epoch other blah 3, you know, it feels okay. But
Yeah,
we'll
I
find
think
out as we
it might
implement.
be. It might work. Okay, so I was going to continue answering to Pawan, but Tony's asking also. There is a reward, but the reward is, in the current implementation, it's very simple. If we feel that the incentives really warrant a change, we can change it. Currently, the PTC member is just is one of the committee members for that slot. So what they get is either the attestation correct or not. So they either miss an attestation or they get an attestation. They get a full reward of an attestation. So it's a very simple way of implementing that. I tried to keep it as simple as possible, the spec changing. I haven't made any economic assurances of whether the PTC, also the PTC changes on every slot because of this design. So it's not something that we're gonna have a problem if it gets owned for one block.
Is there a PTC look ahead? Like 2 epochs
it's same
or
as of
something?
attestations.
Yeah.
It's you just get the last few members of each committee in the attestation committee. But also the PTC doesn't change your head. So if you have seen a payload, it doesn't matter what the PTC told you. That payload is your head. So it only affects against defending against attacks. It's not that the PTC is going to force you to not see a payload. So the thing with all of these extra designs, which I think it's actually quite nice. I haven't done. I mean, smarter people than I are looking at this, the economics designs of slot auctions or whatever it is. What worries me of all of those is the fact that if you haven't committed to a particular payload, then the execution proposer can produce different valid payloads. And if you have different valid payloads, so if you have equivocations on the payload, the attesters need to vote on which one is the head. And if you run an attestation scheme to count and give them LMD weight, then now you need to worry about slashing conditions for the equivocations. That's the reason we have safety, because we have those slashing conditions when you attest to contending branches. So this was a blocker for a long time, but then it just hit me that this is not really a blocker, because these slashing conditions are for FFG, and the payload is not committing to a particular payload, but it is committing to a particular target vote, because the payload corresponds to a particular consensus block, which already specified what the target is. That means that you cannot have equivocation on targets. So it means that for slot auctions, at least, it seems that we can just use the exact same EIP and just change. You should not commit do not commit to a particular payload. And we can do slot auctions easily. I haven't included this because, well, it seems like an easy change if it's deemed safe. And for execution tickets, it's different because execution tickets don't even commit to a target. Execution tickets are by the protocol they are sold. You sell the right to produce a payload in a future slot, and that future slot, well, might be in a different epoch. Therefore, you're not committing to a particular target. So an equivocation actually can equivocate on FFG. So, and this I do not know how to solve. So I think execution tickets, my impression is that it's impossible without increasing the slot time.
So in the case of ePBS, it would, you can't have like equivocation, but you can basically have this payload exists or doesn't exist, sort of in terms of fork choice.
Oh, well, right. But the thing is that attestations are not, so there's not a round of attestations for the payload. Attestations are only for the CL block.
Okay, makes sense, yeah.
So an attester cannot even equivocate. How big is the PTC commitment currently is 512 validators.
Yeah, I was just thinking because this is starting to sound like the sync committees, and then we have honest majority assumptions, and yeah, it's just worth thinking about.
Yes, so we did
It's
that.
secure
We
enough.
did do that computation. We checked that it's like the average time for a 33% staker to take over a committee is something like 30,000 years or something like that. So
Okay.
it was fine.
Yeah.
512 was fine. The thing is that this is a global topic, so it can't be too large because everyone needs to listen to this topic. And I was hoping for 256, but that was perhaps too small. No, PTC commitment rotates every slot, Tony. No, Gajinder is asking that. Every single slot, we change the PTC commitment. Everyone is listening to that topic, and everyone is computing the committee, the beacon committee for attestation, so it's easy. I'm not following. Guys, can you speak up instead of like writing in the chat? We're not that many. It's easy to have a conversation.
Okay, yeah, I was just asking whether the members that are selected to be part of the PTC committee just don't have incentives to give good attestations as long as they are part of the PTC committee now, since they get rewarded based on their PTC contribution and not on their attestation.
They are not, their attestations are ignored. So
okay. I see.
The attestations of so they are removed from the beacon committee and they are added to the PTC committee of that slot. So their attestations, they only get a reward if they attest for the right thing. And it's a little bit tricky in the sense that, so there are a few things that are not specified well because I figured that this is not worth to add complexity. But the proposer needs to pack these attestations in the block so that we achieve consensus on whether reward them or not. Specified that the proposer can only pack PTC attestations for the last slot and no other slot. So that means if a slot is missed, then every PTC committee member will lose one attestation. This didn't seem to me like a bad thing to do. Also, there's no checks that on equivocations of PTC attestations. So in principle, a PTC member would be inclined to sign both. It's present and it's not, or even three. It's present, it's not present, and I've seen a withheld message. Because the proposer will include the right one and that's it, and it wins. If the proposer includes equivocations, there's something that is added there to penalize the proposer for including the wrong thing. But there's no penalty for proposers colluding in that way, that if they see every attestation, they choose the right one and they include it.
Okay.
I figured this is just too little money to be worrying about. And
also there's no like any slashing conditions for PTC member equivocating, right?
That's right. So that's why. So the slashing is that if the proposer includes them both, then the proposer is penalized. But yeah, so I haven't I don't think there's a danger. Perhaps there is. I don't know. Yeah, I don't know. Perhaps if the majority of the network is malicious and everyone sends like all possible PTC messages, and then the proposer of the next block chooses which one to include, it might have an issue. It's something to think about. That's good to add to the notes.
Then effectively, like it's the next slot proposer who's choosing whether like the payload was seen or not in some sense, right? The PTC is completely useless in that case.
Well, that's only if the CL. So here, the PTC is chosen randomly. So you're assuming that the PTC is malicious. That means that the majority of the network is malicious. And if the majority of the network is malicious, then yeah, anything can happen anyways. But if for some reason the PTC clients, they are hacked on whatever, they're modded so that they send all attestation, but the network is still honest, then it's not good enough. The next proposer, so this is an answer to Roman, the next proposer cannot reorg the payload or not reorg the block just by looking at the PTC commitment, because the fork choice is given to the CL vote.
So why can't we have PTC slashing on PTC vote equivocation, in the sense that they are waiting for the same block but in different outcomes?
We can. Slashings are just difficult. Slashers are expensive. You need to add these conditions. You need to add processing. It's complexity that it's not. I wasn't sure if it's worth it.
In the gossip rule, we could still apply the rule that we send over the network only the first for the same,
it's already there.
So it's already there. So it means that the second option and the third option are less likely to be distributed over the network. So
yeah,
but definitely less effective.
Also, in the case of
everything.
if we wanted to add a slashing condition, it would essentially be a double vote slashing, right? That's the only thing that a PTC member can do.
That's correct. But also, this requires also the proposer of the next slot to be chosen correctly, right? Because you need to achieve quorum. So you need to have at least half of the network that signed for the same thing. Yeah, around the PTC side, I'm not particularly worried. The only thing that worries me is that the PTC vote gets on time. In the happy case, it seems that this is going to be easy because, well, the payload is going to be available at 4 seconds. The PTC committee can vote for it at 4.5. So the current deadline is 9, but I expect that on the typical slot, we're going to see the PTC vote at 4.5. Modulo something that I haven't told Rick to analyze. There's the following problem. This is a problem. The builder of the current slot sees at 3 seconds or 2 seconds or whenever the payload appears, he sees a commitment to his block. And he has that information. He knows that block. No one else does. So question, does the builder delays the broadcast as much as possible or not? I do not know.
Wait, why would they want to do that?
Do that because it's is it adversarial? Because then like other people don't have information on time to start building the next block?
Exactly. And I've been told by Flashbots, when I gave that speech to Flashbots, they told me it doesn't really matter because the 6 seconds that anyways by default the searchers will have is more than enough to search and to build. Oh shit, we're already in 50 minutes. I feel like I took over this meeting. Anyways, so I've been told that this is not really an issue, but it's something to keep in mind that it might be. I hadn't realized this until a couple of weeks ago.
But then I also
that's interesting.
Yeah, sorry, but it's also like I don't think we have visibility on the builder game. This is something we probably will need help on talking to the builders. They will be able to give us input. Because if you really play the builder timing game, right, you can get like 9 seconds to build versus the next builder can only get 3 seconds, because I will just delay my reveal at the very last second of the PTC deadline, such that I only get 3 seconds. And I suspect there may be a compounding advantage there. If today I win the slot, I win the next slot, and I can just keep playing this game and just be the winner forever.
In that sense, it really does sound like a proposer timing game. Like if you play the game like all the way, like you can like if everyone delays to the max, then everyone gets the exact same reward. But it's still interesting to look at.
Yeah, so this is one of the reasons why Barnabé suggested that we shorten the deadline for the PTC vote so that the builder is forced to broadcast immediately. And so we shorten the time between PTC vote and builder's reveal.
Yeah, that sounds also kind of right, because the builder is supposed to be sophisticated and well connected anyway, so it's not like, well, like,
yeah, and in any case, anyone that is a home staker would be revealing like 6 seconds before, so it's not a problem for home staker. I'm not against this. It seems the right thing to do that. Guys, we have like 8 minutes. I know you have said that you haven't started implementing it, but I wonder if you have questions about like or opinions on what do you think it's going to be hard, what do you think is going to be easy, what do you think we should probably change?
I think one thing is that if you look at our current spec, it's gonna change. Our current spec has inclusion list in there, and I don't think inclusion list will be part of the EIP. So you probably won't. Yeah, so don't look at the current spec. That's POTUS PR number 2.
Yeah, I promise. I'm traveling tonight. I promise that in the next few weeks, like say 2 to 3 weeks, I will try to have the EIP ready. It's not really clear that's going to happen, but it should be soonish that the full EIP will be opened, and it's going to be without inclusion list.
On the LOTSA side, I would like to start working on it as soon as basically the spec is clear and the documents are available.
So if you take the current spec, so Terence says not to look at it, but if you take the current spec, it's trivial to remove inclusion lists. So just grab the current spec and remove everything that says inclusion list. The documents are completely, so if you look at my hackmds, I put an entire annotated spec already. Like every single function is annotated in those hackmds. There are 2 large hackmds. One is purely for port choice. Port choice is not changed except the availability of the inclusion list. And so you can just either assume that we could, for example, implement an EIP with empty inclusion lists by default. That doesn't touch the EL. So we could ship ePBS with empty inclusion list.
So maybe if I can get to study, I mean, is there any place where those links are handy?
Yeah. So my pool has everything. It's just that I'm opening up. Let me just. Yeah. There's every large. Look at the 2 links in that pull request. That pull request has all of the specs.
Itself.
Is it 1 or 2? Which one is the right one?
It's the second one. Yeah, 2.
The second one doesn't have MaxEB and to 7002, so it's easier to read. The EIP needs to include them because it's going to be on top of Electra. It's going to be harder to read on top of the NEB.
So the implementation you guys are doing, it's on top of Electra?
Well, it was on top of the NEB, and now we're moving to the top of Electra because I'm hoping that it's actually going to happen on the fork after Electra. I mean, of course, if everyone coincides and everyone has everything ready, then I'm going to push for Vectra, but I'm hoping that this is going to be in the F fork.
So this is Electra 3.
Sorry?
I mean, I was just joking that this is Electra 3. Electra 3.
What? Oh, Electra 3.
think it's a joke. Yeah.
Yeah. So okay. So we have like 4 minutes. I'm not sure.
So one thing that
What?
you brought up, I missed earlier is that like for the sync committee, the current deadline is 4 seconds, right? Does it make sense to change the sync committee deadline between 4 seconds to 3 seconds to align with the
Oh, yeah.
attestation deadline? Right. Yeah.
Shit, I haven't even thought about this. Yeah. Yeah. Yeah, it has to be the same. I haven't touched the sync committee spec. Okay, someone take note of that.
I do have a oh.
Well, Tony put a lot of questions. I can reply to what the spec says today. Who does that job? Beacon committee members. Because we want and I have a good understanding as to why this has to be the case. We want that committee to be changing every slot so that it's not taken and you cannot own several blocks in a row. And the Beacon committee already does this. So you can just take the same sapling. Is it rewarded? Yes. And it has to be rewarded. Do we want it to be very much deeply rewarded? I don't see why. The committee is chosen at random and threshold is 50%. So you're already broken anyways if you don't take 50%. So I think just an attestation is fine. Vanilla clients are going to be enticed to attest correctly. Interference with attestations, I don't know what that is. PTC can easily get split viewed. It's fine, but it doesn't help anyone. So the builder that wants to create a split view, it's useless because the next proposer already syncs the view. So the builder can only damage itself. It's not going to create a fork at all. The payload is either there or it's not there. The PTC only gives a boost. So the next proposer enforces the boost, and that's it. So PTC is not really important. The PTC is only there to give a guarantee to the builder. So the builder is inclined not to overload the PTC. The builder is trying to use the PTC.
So the revealed payload is bundled with the next block or not?
No. The payload is sent by the builder, and it's processed in the CL as just a new block type.
So if the next proposer, I mean, it's basically colluding with the previous proposer and the payload is not revealed, would it cause any issues?
I'm sorry?
So if the next proposer is colluding with the current proposer and the payload is not revealed to most of the people, and let's say the PTC vote was not enough as well, so would it cause any problems?
Can you repeat? So you have proposer of n plus 1 colluding, and
yes,
and the builder doesn't reveal.
And yes, so basically n proposer gave the payload to builder n plus 1, to proposer n plus 1, but the payload is not revealed to the rest of the validators. So would that be an
Yes.
issue?
No. No, not at all.
Because
All of
they
these
would be-
cases are analyzed in this 4-choice situation. Like if the proposer of n plus 1 produces a block on top of payload that you haven't seen, then you cannot even validate that block until you get the payload. It's just the same as today. If you're a proposer and you hold 2 blocks in a row and you withhold your first block and then you send the second block, no one is going to sync that block until they get your previous block. It's exactly the same as with 2 consecutive consensus blocks.
Another thing I was wondering, it just because the idea came out in my head now, is there a possibility to make sync committee being the PTC as well? It means that you have the same sync committee that starts voting for PTC as well, instead of you don't have So new messages, you just change the messages, and this vote for two things.
Oh, you want to overload the sync committee so that you remove sync committee attestations and you put them on
I
at 9
want
seconds and you
them
do vote.
to vote on two things. So they play the role of the sync committee plus being the PTC. It depends by when the sync committee happens. If the sync committee happens in a consistent way compared to the PTC, they could be moved.
Yeah, this is probably doable, but the problem with that is that sync committee attestations are aggregated, and so PTC attestations cannot be. This is the reason we wanted to have a very small committee that can attest every slot, and the attestation needs to quickly get to every node.
Right, there is a round of aggregation in the sync committee as well.
Yeah,
And
so
the rotation times are also not same. Here we want rotation every slot.
Yeah, I mean, you could give up on this rotation if that makes sense.
I agree that we could overload, but then we need to remove aggregation on sync committee, and that I think, but also having a long running committee like this, that's takeable. That becomes a danger.
I see. Right.
Someone asked about incentives. I think this is probably not a discussion to have 2 minutes before the end of the meeting. We'll probably add this to the agenda in the next breakout in 2 weeks.
Yeah, next breakout. We could take an hour just on that question.
Yeah, there's already like a lot of literature on that. If you look at my own slides, there's a good argument against the document by Mike and Thomas and company on relays after ePBS, and I think I'm always thinking that we have the right design. All right. So if there's nothing, we can probably close here and meet in 2 weeks, hopefully with people doing something.
Also, feel free to drop the questions in the ePBS Discord. I think there's a few questions that we missed to answer, but yeah, just drop it there. We'll help answer. Thank you, guys.
Thank you very much for everything. You took notes, Terrence, right? There were some
yeah.
good points.
I will share notes after.
Thank you very much.
Okay, bye.
See you guys.
Thank you. Bye.
Thank you.